We're just waiting for a few more people to join us, so we'll start in 5 to 10 minutes. Hi everyone, we'll be starting in just a few minutes. Are you all able to hear me on Zoom? Are people on Zoom able to hear me? Oh, okay, perfect. Hello, everyone. I think we'll get started now. So to start with, my name is Arushi. I'm a junior here at Barnard studying econ and math science. And I'm going to be conducting the first half of this workshop. And then after I do that, Grace will pick up for me. Do you want to introduce yourself?
Hello everyone, my name is Grace. I'm currently a senior at Barnard and I'm double majoring in math science and econ stats. And it's great to meet you. As Arushi said, I'm going to take care of the second half of the workshop.
So let's get started. Let me share my screen here. Okay,
Arushi, sorry, just 1 second. Stop the share. And when you redo it, choose screen, the first one, because otherwise you'll have to keep switching when you do R or something else. So when you click on it,
oops.
sorry, you can see there's a little lag here. And then choose that first option. And then click share. Zoom takes a second.
All right, so if you can all just go to this website, it's erc.barnard.edu, that's our website. And so you can, so all the fellows here, including Grace and I, we can all help you out with any projects that you have that require different statistical softwares. To see what fellow specializes in what skill and what time you can come visit us, just go to the Visit Us tab. And if you scroll down, you can see our walk-in hours for each of us. And you can see each fellow's skill set. So based on that, you could just match with their times and drop by anytime you want, whether you just want to pick up a skill for your resumes, or if you need help with homework or projects. So everybody here will be more than happy to help you out. And so now moving on to the workshop portion of this, if you go to the website and click on the workshops portion, is everybody there? You can either do this on your own computers if you already have R installed, or feel free to use one of the ERC computers. I think everybody is good with that. Okay. So if you just scroll down to Spring 2022 and you click on Introduction to R, click link. And you can just download if you click on this little button here that says download, just do that. You should get a folder that's downloaded. For those of you who are on Mac, you should be able to open the files directly. But those of you using the ERC computers, you'll need to do an additional step. So you click on this. You can go to desktop and create a new folder. Let's say, okay, let's call it our workshop. And we go to downloads. And you
just
can,
wait a second, and if you want to just walk through the steps really quickly again,
Sure.
just in case of people listening.
was everybody able to download the files? Okay, and then so you'll need, so those using the ERC computers, you'll need to click on extract all. And once you click on that, it'll ask you to select the destination. If you're all there, extract all is at the very top over here. Sorry about that. It's right here. If you can see my, so just click on that, and you can select the location to be the file that we just created. So in my case, it was our workshop on the desktop. You can click that folder, and then extract.
If anybody's having an issue with the extract, I can also come around.
Yeah, so Denise and Fatima are both here to help if you're having any issues following along. Oh, to download R, you need to, okay, so if you need to download R, you can go to the CRAN website, I believe, and you'll have to download the software from there.
Oh, yes, so if they're following along virtually, there's 2 ways they can do it. So we could log on to a portal, the virtual desktop. Have you used the virtual desktop? Whoever is asking, Angela? Okay, let me just give them those couple of links. Where is it? Okay, let me just post the couple of links for people. Okay. So you have a couple options. If you want to download R. Oh, you have to, okay, this is for Windows. Okay, so on this website, you'll find R downloads. And then once you download R, you'll have to download R Studio. If you don't already have R, I would recommend either just following along, or what you can do is use Barnard's virtual desktop. I forgot what it is, Barnard.porter.com. And you could log in here, and that will give you like a virtual computer that you can follow along from.
So that already has R installed, so you can use that.
Yeah, exactly. So that would already have R, and you wouldn't have to download it to your computer. If you want to download, it's those first 2 links. All right, anybody else have any questions? Just in like that getting started process. All right, here you go, take it from here.
Perfect. Okay, so now that we've extracted our files, click on Introduction to R Workshop student version. That's the file. So you'll see that it's an RMD file. So if you can open that, so it's an R Markdown file, which we'll talk about in just a minute. So that should. So for those using the lab computers, it's automatically going to open it in EndNote. So what you need to do is right click on the file and go to Open With and select RStudio. Yes, this is recorded. So you'll see an RMD file up here. Okay, so welcome to our introduction to R workshop. This is part 1 in a series of 2. This week we'll be giving you a basic introduction of just the different elements that make up R and some basic code so that you're comfortable and building from that. And next week we'll be diving further into data analytics, visualization, etc. So definitely join us for that if you enjoy this one. And so let's get started. So firstly, why do we learn R? So R is becoming very, very popular, especially in the last 5 years. So some of you might have had experience previously with Stata, Excel, and other statistical softwares, but recently we're seeing immense popularity rising in R usage because it's used by statisticians in various different fields, be it biomedicine, stats, psychology, economics, etc. So it's also an open source program, which means that so there's a wide community available online for you to share and collaborate. So it's a lot easier to be able to code, just given the large community of users that it has. And the biggest reason is that it's completely free, but Stata isn't. So this is also why we're using R more frequently, and it just provides you with a more friendly user base, which we'll see in just a second. And so it's a programming language for statistical computing, graphics, and it's used extensively by researchers, statisticians, data scientists, etc. We use it to import data from our computers, from different websites or databases, just depending on what you're using R for. Some of you might be using it soon for either class projects or for your senior thesis if that's coming up. So this would be super helpful for that. You can also clean your data very easily by organizing it into matrices, data frames, or tables. And you can run several statistical tests and graphs and do a lot of data visualization if you need. And lastly, this is my favorite reason for using R, is that you can communicate your results as well in the same place. So rather than having to first run a bunch of tests on one software and then having to use something else to be able to communicate those results, R allows you to do all of that in the same place using the Markdown feature, which is what we'll see. And just to show you what that looks like, if you go to your RMD file, and what we see over here is, so you can, if you see at the very top, so this section is the Markdown section, as we call it. And you can knit this, but if you click on knit at the very top over here, that little like wall knitting icon.
But with this file, it's not going to work, right? You have to do it with the new file.
Oh, sorry. Yes, this has some unresolved code that we're going to tackle. Sorry about that. Okay, I'm just going to open a new file and Markdown.
You don't have to create the new file. That's just for her to show you.
Oh yeah, this is
how the
just
Markdown
so
file
you
works.
can see what I'm talking about. And knit. I will call this test file. And I see my RMD file. Let me zoom out this. So here is my Markdown file in Word format. So this is super helpful for class projects, and a lot of you will have to submit your findings in either Word or in PDF format. So over here, it was a Word document. So I have regular text that I would use to write my research reports, for example. I also have some summary tables for some of the statistical tests that I could have run. If you include plots in your R Markdown file, that will also show up in the same document. It's a very cohesive way to organize your research and present, for regardless of whatever use you're doing it for. So that's one of the best features that R offers, which is the Markdown feature. And again, so I chose a Word document here. You could have an HTML format or a PDF, just depending on what your needs are. So to close that. Okay, so moving on. And we're going to be working towards our own Markdown file by the end of this workshop. So you'll have something to show. Okay. So if you see on your over here, so we have 4 different panels that make up R. The very first one highlighted over here. This is you can call it your text panel or your Markdown panel. This is where you're free to use either regular English if you want, like we saw on the Word document, if it's just some text that you would introduce in your project, you can do that over here. You can also include code chunks over here. So if you wanted to run specific code here, you could easily do that. So this is a space where we make that final document that we end up getting when we knit our document. This panel at the right below it is called the console. This is where we run our code. So we run our code here too. We can test out specific code, for example. So what R does is we can run code and we'll get our outputs, but it may not necessarily, if we don't want it to, it may not necessarily hold on to those outputs. So this is just, for example, if you're working with a new function or a new command, this is a good place to test that out to see if you're getting the output that you're expecting it to. And over here, this panel is the environment panel. So what we'll see over here is during the course of the workshops, as we define variables, we work with different data sets, different functions that we may use. So R helps us keep track of what all we're using by displaying that over here. So for example, we'll see later, if I introduce a variable and I've assigned specific values to it, that will all be displayed over here for us to see and to be able to access easily. And lastly, this panel, so this has so much going on. There's the files, so which will show you existing files in your R directory that you can access. If you generate any plots, those will also show up in this section. Packages that you may use, and we'll talk about packages in the next section. And there's a help bar, which if you're using a new function, for example, R will give you all the relevant information in that section. So there's a question. Oh, sorry. And yes, so now we're going to talk about making the best of our Markdown and using variables. Does anybody have any questions so far? Okay, let's move on. So what are variables? A variable is a stored space that we can manipulate and mutate using code in R. And we use this because, so for example, as I had mentioned earlier in the console, if I wanted to run specific code, so if I wanted to use 2 plus 2, for example, I get my output here. Similarly, I can do that for several arithmetic functions, divided by 4 to raise to 3. And if you wanted exponents, for example, or the natural number, you could do that using the exp and parentheses. So that's how you would do that. For logs, that some of you might need to use. So what R does is it assumes that your logs already have. It's a natural log, so you can either do that if that's what you need. So I'm going to take the log of the natural number, which should return the value 1, but let's test that out. So all I've done is log, open parentheses, exp, again, open parentheses, the number 1, and then close both the parentheses and I get 1. But if you wanted to change the base of our log, we could easily do that. So again, we would just say log, open parentheses, for example, 10, and I want this log to be to the base 10. I would say base equals 10 and run this, and I get my answer. So the reason we use variables is that although I'm getting my outputs here for these different math functions that I've run, R isn't storing these values. So if I wanted to refer back to them, I wouldn't be able to. And a lot of times when we're running actual projects, we don't want to keep running the same calculations over and over. So what variables let us do is they tell R that we're going to be working with those values, to store those values until we change them or alter them in any way. So what that looks like is this. So for example, if I wanted to assign the value 5, and I want to continue to use that value 5. So for example, it's somebody's age, and I'm going to keep referring to it. The easiest way for me to do that is instead of having to type 5 over and over again, I can use a variable called x, and I would define that in R using the arrowhead and the dash, as you see. So this tells R that x is now associated with it holds the value 5 until I change it. So variable name and the value. So there's 3 types of variables that we use. So there's the integer and numeric, like the ones I just shown you. We have x equals 5, which is a numeric variable. We can have character variables, which are words for text, or logical, which are true, which hold true or false values only. And if you look at your RMD files, we'll see that over here. So if you look at line 39 on your RMD files, we've defined our variable over here as x equals 5. And I'm going to try to run that. So there's 2 ways you can run it. You can either go to the line that you want to run, click at the very top, and click on run selected line. So you'll see run at the top and click on run selected line. Or if you're on a Mac, you can do command return. Or if you're using one of the PCs, you can do control and enter to run the code.
Are there any questions so far?
Oh, this is the RMD file that you just seen that you just downloaded.
Yeah.
It's line 39. Do you have to scroll a little?
Oh, on. Okay.
Do you see it?
Yeah.
Oh,
Anybody else
sorry.
have
Does
any
anybody
questions?
else have any questions?
Anyone on Zoom have any questions?
And the way to test, so as we see over here in our environment tab, we see that R is recognized X to hold the value 5. So this is what I was talking about earlier, when that it's easy to track what variables and functions you're using in the environment tab. But for example, if I'm running a very large program and it's not easy to often see all your variables in the environment panel. So what you can do is now to test if R is recognizing this variable, all I have to do is write X, run that, and I get an output 5 in the console at the bottom, if you can see over here, showing that R is now X is storing the value 5. I can also do this for arithmetic functions, for example. So as I've shown you earlier, instead of having to do the math over and over again, I can store the output of a particular mathematical function in a variable, as you can see on line 42. Is everybody able to see it? We're saying y arrowhead dash 2 times 3, 2 star 3. And I'm going to run this. And now to see, again, I'm seeing y over here in the environment panel. And I'm just going to enter y, which is a variable name. And I get my output 6. So these were numeric or integer variables. We can also do the same with character variables. So for example, I want to store the words in a variable. The way I'm going to do that is Z arrowhead dash double quotes or single quotes. So you can use, we're going to be using double quotes here, but the only thing you have to keep in mind is if you start using single quotes, then you need to be consistent. So if you open with single quotes, it needs to end with single. Same thing for double, but otherwise it doesn't matter. You can use either. So I'm assigning the value words to the variable Z, and I do that the same way. It's the variable name, arrowhead dash double quotes, and whatever value I want in there. In this case, it's words. I'm going to run that. And now to check if it's working, I'm going to select this code. I'm going to just enter Z, which is variable name, and I get my output words. Okay, so a question for you all. Can you try to create a character variable containing your name? And you can name the variable name and just assign your name as a value to it. I'll give you 10 seconds to do that. Okay, so I think you should have had it by now. Can somebody help me write that code? So does anybody want to share what they did? Oh, it's right here, line 49 on the RMD file. So you're just defining a variable and storing your name in it. Oh, go for it.
Okay. Dash. Oops. I'm on this bit.
Elizabeth?
I'm on this bit.
Okay, let's run this. Oops, sorry. There we go. So we see variable name, your name in there. And to check, again, I'm just going to say name, and there we go. And the same thing holds for logical variables as well. So over here, I have a variable name called condition, and I'm assigning the value true. So remember, for this, you can only have true or false values. And you may notice that we're not using double quotes here because it's not text. The second we use double or single quotes, we'll treat it as a character type, but over here it's a logical variable. So we want to make sure that we don't use quotes. And the way to write this is either true or false in all caps. So if I wanted to change this, it would be FALSE in all caps, and you will see that our colors it differently. And same way, I'm going to assign this, run it. And I'm getting my value. Now, for example, some projects are really long drawn out. You may want to check the class type of your variable, what type it is, and often it's not easy to see that in the environment if you have a lot of variables and a lot going on there. So gives you a function to check what data type or what the class of the variable is. So the way to do that, it's a function called class. So you can see on line 65 over here, it's CLASS and open parentheses, and you can write whatever variable class you want. In this case, I want to check what my variable class holds, what type of data it holds. So I'm going to run that. And it says numeric. Similarly, if I wanted to do the same for the variable welcome, it would just be class and the variable name in parentheses. Oh, so the reason I'm getting that error is because I have the code written here, but I didn't run it. So don't do that. Always run your code before you're using it. And now I'm going to check class, and it says character. And so I just did welcome. Can somebody help me with checking the class for the variable condition? Does anybody want to try? I can start us off. So it's the function class. And it would just be the variable name. I get the output logical because it holds the value true. And so those arithmetic functions that I'd shown you earlier in the console, we can also do that using variables. So for example, so we know that X holds the value 5 and Y holds the value 6. So I can, instead of adding 5 and 6 individually, I can simply use the variables and perform arithmetic functions on them. So I can just say X plus Y. So as you would do normal arithmetic operations on numbers, you can do the same on variables. So I run that, I get 11. Same thing for Y divided by 2. So Y holds the value 6. So I'm going to divide that by 2, I get 3. And if I wanted exponents, if I wanted X raised to Y, which is 5 raised to 6, I would get my answer. So variables make it very easy to function with code. This is particularly useful. So normally we would name our variables something meaningful to our project. So if you were running, for example, your project is something to do with children and their ages, so your variable would be name and age, for example, so it's something easy. to refer to, but in this case, we're just using random variable names. Okay, so a bit of a challenge for you all. Can anybody help predict what the following lines of code would output? You see on line 87 of your RMT file. Is everybody with me so far? Do you want me to go over something again? So this, can anybody predict what the output of this would be? Just X plus Z. Good for it. It will return an error, let's see. You were right. Because it's too, do you know why? Exactly. So we want to make sure that when we're using arithmetic operators, we have to make sure that it's the same class type. So X over here is a numeric variable, but Z is not. So that's why it's giving us an error message. So we would have to be mindful of that, which is why the class function is something that's useful so that we don't run into errors like this. But if we do this, for example, so we've assigned the value 5, and now we're assigning the value 7 to the same variable. Do you know what the output would be if I ran all 3 chunks of code, these 3 lines? So I'm initially assigning the value 5, then I'm assigning the value 7 to the same variable, and then I'm checking to see what the value is.
Monday afternoons, come on, let's get some interactivity. These are not trick questions. And it's okay if you get it wrong too. There's just a learning space. There's only 2 options, so it's 50-50 if you take a guess. 7.
Let's find out. So I'm going to run the first line. I run next line. You were right. So again, we use variables if you want to manipulate our data, and this makes it easy instead of having to go back. So for example, if you had a very long code, you would have to go back individually and change each 5 to a 7, but this way it will just automatically update X to 7. So that was variable assignments, and now we have data objects in R, and Grace will pick up from here.
Any questions?
Oh, yes, anybody have a question?
Yeah, definitely.
No, that's a great question. That's like the hardest thing when people first get started with a programming language.
Okay, I guess I'll go ahead and show how to run the code. So for example, in your chunk, you can put your cursor anywhere on a specific line that you want to run. And then on the top, you can see on the top bar, there's this run with the arrow, and you click on the arrow and you can say run selected lines. Oh, this is actually not going to run, so I'm just going to demonstrate with one that is going to run. So this is way number 1. You can run this code. Another one is that you can still put your cursor on the line you want to run. And the shortcut for the lab computers are Control Enter. So you can hit Control and then Enter. It will also run the line for you. And for Mac, it's actually Command Return. So it will do the same thing. Perfect.
That work for you?
Did that work?
Grace, you might have to talk a little louder. I'm not sure if it'll
Okay.
get caught in the recording.
Okay, I'm gonna talk a little louder.
Sorry.
Right. Are there any other questions? No, we're good. Okay. And if you are using one of the lab computer and when you open this file, on the top of your file, when you see a yellow bar that says you need to install some package, you can go ahead and click install, because that's probably the package that you will need later to actually knit your file.
Only some of you will have it, not all of
Yeah.
you will have it.
All right. If there are no further questions, I'm going to go ahead and introduce data objects in R. Okay. Um, So data objects are a very elementary sort of building block of R, where you can apply different functions in your object. And in the workshop today, we're going to be talking about two different types of objects. The first one is called vector. The second one is called data frame. So we're going to go ahead and start with vector. So with a vector, you can think of it as a sequence of value of the same data type. For example, in the example that you can currently see on the screen, I have a vector of all numeric values. So all of the numbers are numeric, and this is the first vector. It doesn't have to be of length 4. It can be of an arbitrary length of your choice, and the length 4 is just a demonstration. However, only having numeric vector is probably not enough in your coding experiences. So we can also have a vector of characters. For example, in here, I have the days of the week from Sunday all the way to Wednesday, and all of them are actually characters. And the way you can tell, well, the first way is pretty obvious. You can see they are characters and not words. The second way is actually they have quotes around them. That is the way to tell R that, okay, I'm inputting a character, so then I put them in quotes. Another type of vector you might see, they may contain true and false values. This is a logical vector. And we will use this later on when we are doing subsetting with true or false values. So another very great things about vector is we can do vector calculations. So if you know another programming language, this very simple process, if I take a numeric vector and multiply by 2, this is a little bit more complicated because you need to go ahead and make sure, okay, I have 1 times 2 and 2 times 2. However, R is really smart. When you have a vector and then you just, for example, this vector is called X, and then you type in 2 times X, it is actually smart enough to say that, okay, I know you mean I'm timing each of the elements within a vector with 2, and then it will output 2 all the way to 8. So we can actually go back to R to demonstrate. So starting on line 95 is the section corresponding to data objects in R. And then on line 99, you can see that I have 1:10. This is a very easy way to define your first numeric vector. This colon is a special operator in R. That means I am creating a numeric vector starting with 1 and adding with 10. And we can try and run this line. You can see in our console region, or if you scroll a little bit down in the output region, you can see a vector is created and the first element is 1 and the next element is 10. And this colon operator creates consecutive numbers. So 1, 2, 3, all the way to 10. And then I can define a variable called A that have this value. And then nothing is printed. So if I want something to be printed, I can retype A again to see our original vector. And sometimes if we define too many variables, we might forget what A actually is. So you can actually check the class of A. So if we run the next line, you can see integers. That means this vector contains integers because 1 through 10, they're all integers. We can also check the length of A by applying the length function. It is pretty trivial in this case because it's 1 to 10. So you automatically know that there are 10 elements in this vector. However, if you have a vector that is extremely long, it might be really useful to check the length. So on line 108, you can see that it is not necessarily the case that we create vectors of consecutive numbers. For example, in this case, I created a numeric vector starting from 1, and then the next element is 3 all the way to 9. So I use this little C here. This just stands for concatenate. That means I have one element and then I'm pasting another element after that. You can sort of visualize it that way. So we can then define a numeric vector containing 1, 3, 5, 7, and 9. And we can print out the results. If we retype B, you can see the results printed. Indeed, we have a numeric vector from 1 all the way to 9. And like we said earlier, we might want to create a vector of characters. In this case, I have a variable called day, and that just contains values from Sunday all the way to Saturday, so different days within the week. So then notice like before we have this C C parentheses, when we are trying to define this vector, that just means that we are passing a lot of in here. And the variables are in quotes because we want to tell R, okay, we're creating a vector of characters. So we can run this line and then have it printed. So the next one is a practice question for you all. So the question is to create a vector of characters that contains your name and your favorite color. So probably take 30 seconds or so to create such vector. Okay, perfect. Does anyone want to volunteer what they typed out? Anyone? It's okay to be wrong. I made a lot of mistakes when I was first learning to code. Anyone? I'm gonna start with a C. No, okay, and a parentheses. Anyone? Okay, I guess I'm gonna do this one. So since we're creating a vector of characters, we have this, since we are also passing in two pieces of information, we have name and favorite color. So we use this C function sort of to tell R, okay, we have different types of information, different pieces of information, excuse me. And since we're passing in characters, we need the quotes, and then within the quotes, for example, I can say my name is Grace and my favorite color is white. And then I can name this something. For example, I can name it about me. Notice that about and me, there are two words. And since we cannot have space in variable names, we actually put in an underscore, or we can actually do a dash. This will also work. So we can define this vector. Let's see whether that runs. Okay, and then I'm just gonna check whether I have the values I want. Okay, so if I run about me, you can see there's Grace and then there's white. Any questions? Yes.
When you're calling on a value using a vector, does the index start at 0 or 1?
The starting index is 1, but we're going to talk about it later. Right. So like I mentioned earlier, there is this vectorized calculation in R. I'm going to remind you all what A is. So I define A to be a numeric vector from 1 all the way to 10. And then I can multiply every element in A by 2 just by typing in A times 2. And if I run this line, I get 2 all the way to 20. Perfect. Practice question. Try for yourself what code you will write if you want to add 1 to the vector named B in the previous code block. Notice here that I didn't insert a R chunk. So in this file, you can see two regions. There is this like white-ish region and there's this grayish region. In the white region, you can type in English or you can type in Markdown syntax, but in the grayish region, you can only type in R code, or sometimes you can also type in comments by having a little hashtag in front of what you're going to write. So the way to insert a chunk is that you go to the top bar where you see there's a plus C with a little arrow, and you can click on that. This top bar where you had the run, and then it's next to it, there's this plus square screen C. And then you can hit the first one because you're inserting a block to write R code. And I can remind you what B is. So this is our B. Does anyone want to help me with adding 1 to the vector B? Yes.
You could say B plus 1.
Yes, that's perfect. So B plus 1. And then I'm just going to run to see. It's 2 to 10. That's exactly what we wanted. Okay, so that's everything about vectors. We can now move on to data frames. So if we think of vector as this 1D vertical list, data frame is somehow 2D because there is now a row component and a column component. For example, on the slides here, I have 2 vectors. The first vector is a numeric vector. The second one is a character vector. I can actually combine them together to form a data frame. Now we see that there are two columns and there are 3 different rows. And those 2 columns doesn't necessarily have to be of the same data type. We can think of the different column as different type of variable, for example, and different role as different observation. So in order to identify the 2 different roles, we give them column name. For example, the first one, I can give it ID because it's like numeric, so it's pretty intuitive to call it ID. And the second one is from Monday to Wednesday, so I'm just gonna call it day. So if we want to access, for example, specific columns, we can refer back to the column name to access the information. Okay, so let's go to R again.
Grace has a question.
Yes.
Like what you mean by observation?
So for example, you have a Excel file containing some survey results that you did, for example. And then you might ask people, okay, what's your name, what's your age, and what's your uni, for example. And when you collect those results, sort of one person's data is in one specific role. But in different columns, it might be different because you ask about their uni. For example, one column will have their uni and another column is going to have the name, for example. So one row of data just represents the data for one person or like one observation. If that makes sense. Any other questions? No? Okay. We're going to go back to the R file and starting with line 137 is the data frame. So the first thing that we're going to do is that we're going to create a data frame by hand. As you can see, starting on line 140, I have sort of typed out a data frame that we're going to create. So the first line, so line 140 is actually what I was referring to as column name. The real data part actually starts from 142. So in this specific data frame, I have 2 rows. This 142 is the first row and 147 is the second row. And I have 3 different columns. The first column represents ID, the second column represents uni, and the last column represents names. Okay, so now we understand the data frame that we are supposed to create. We can write the R code for this. So the function is just called data.frame with the parentheses. And you input the data column by column. For example, the first entry you see here, ID equals to 1:2. You first write the column name of the specific column. Since our first column is called ID, I'll write ID equals. And after the equal sign, I put in the specific data I want to put in with that column. So before I said 1:10, that means 1 all the way to 10. Since in this case, we only have 1 and 2, I'm just going to write 1:2. And that's the end of column 1. So to tell R that we're done with entering information about column 1, we put a comma after. And then after the comma, we can start inputting information about the second column, where there's a column name that's called uni equals to the specific value. You can think of the specific value as the vectors because earlier we created a character vector using a similar syntax and then followed by a comma. And then we have this third column that is called name. So we can run this code and then have it printed out just by typing ERC fellow again. And we now can see the beautifully printed data frame in our results region. So in vectors, we have this length function that checks how many elements are in there. However, if we check length on a data frame, R gets confused because it doesn't know how, yes.
Wait, can you ask that ERC data? Oh, I mean, data.
Any more questions or errors with learning the code? No? Okay. I was already saying that we can also check for sort of the length version of the data frame. We can check the dimension. It's a dim function, DIM, that's online with 150. So we can write dim parentheses and the name of our data frame. We have the data frame name ERC fellow. So on what if we run 150, we can see that there are two values printed out. There is this first value that is 2. This corresponds to the number of rows in our data frame. So there are 2 rows. Indeed, we only have 2 rows in our data frame. And the second value actually corresponds to the number of columns. So we have an ID column, a uni column, and name column. So we have 3 columns. And you can also directly check all of the column names. For example, if you run 151, this will print out all of the column names you have in your data frame. This is pretty trivial in this example because the data frame is extremely small and you can directly see it and tell me the values. But if you have a huge data set, it's really useful to check the dimension and to check the name just to get a sense of what the data would be looking like. So practice question. Suppose you want to create the following data frame. How would you code this? Since there is like a bit typing with this question, I'm going to give you guys 1 minute. Feel free to talk to the person around you. And yeah, 1 minute start now.
If anyone needs any help with it, I can come around as well.
Okay, we have about 10 more seconds. All right. So what we can do is that we have data.frame, the original function, and in this function, we put in our information column by column. We have age, and since these are not consecutive, we actually need to put it in one by one. So we have the C function with 10, 20, and 1, and then we separate the first column to the second column with a comma, and then we input the name, the hometown, etc. I'm gonna run this, and we can see it printed out in our output region, and this should match what we had previously. So the one starting on 156. Perfect. So instead of creating a data frame from scratch, we usually use this read.csv function to actually read in a specific CSV file in your computer, and we sort of turn it into and then it is read as a data frame, so we can later do data manipulation. So the function itself is called read.csv with parentheses, and then within the quotes, we actually tell it's the path. So a way to understand the path is that, for example, you turn on your computer and you know that there's this specific file that you want to find, and then you can open different kind of folders in your desktop, and then you finally land to this file. So the path is a way for the computer to sort of find this file on, for R to find this file on your computer. So notice here, however, I don't actually have the path. I have the name of this file. That's because this RMD file and our data file are in the same folder. So actually defaulted to know that, okay, we're referring to this folder. So just by directly typing in this CSV file's name, we will be able to run this. But depending on the setting of your computer, this code might or might not run. So if you try to run this code, but you have an error occurred, please raise your hand and the fellows in Fatima Denise will go around and help you to load the data. If there aren't a lot of questions with this command, I'm gonna move on to the next line, if that's okay with everybody.
Yeah.
Okay, perfect. So I'm gonna go on to line 173, where we check the dimension of this data frame. So if we run this, we can see that two numbers are printed out. The first one corresponds to row, the second one corresponds to column. There are about 728 rows and 12 columns in this data frame. So we can also check the column name of this data frame. So by using names df, we can see a lot of names get printed out. I'm going to very briefly mention to you what these are. For example, the name here. So this data set is from Kaggle, and we're looking at university versus your STEM percentage, how many people in your school are STEM, and versus their predicted career pay. For example, you can see early career pay. That means the predicted career pay that you're going to get when you, for example, for me, just directly after college, how much I'm going to be paid as predicted. And mid-career is I leave the university for about 10 to 15 years and how much I'm gonna get paid. And that's a predicted value. STEM percent is how many percentage of the students in your school are STEM. And in-state total and out-state total, these are actually tuition fees. So whether the type of your school is a private versus a public, they might differ. So to actually view the data set, since you've already read in this file and name it DF, we in the environment tab, we can click on this DF. The environment panel is the top right panel, and the first one is supposed to be this DF. You can click on it, and this will actually take you to a page where you can see the actual data. And for those of you who are curious, the actual command that was ran when you click on this is actually view DF. But we can directly click on this DF variable to see this data. And you can probably drag it along to further see some numbers and different types, etc. I'm gonna close it for now. Okay. And a more common way to actually see the data frame is to print out the first 6 rows to get a sense of what the data looks like. For example, by running this head df command, we can see the top 6 rows. And sometime with the data frames are organized very nicely in the head region, I mean the first 6 rows, but not so in the last 6 rows. So you can also use the tail df to check the last 6 rows. And then with this little black arrow, you can go back to see different columns. Okay, so that's with the data frame. Next, we're going to move to subsetting. So subsetting is a very powerful tool in different programming language that allow you to access specific elements in your data object. For example, if we have a data frame that have 700 rows, we might not want to look at all of 700 rows. We might want to look at a specific section of that data, and that's why we use subsetting. So first, we're going to talk about subsetting vectors. So we will use this variable name square bracket index to access the element. So what do I mean by index? So we have this vector in gray that has Sunday all the way to Wednesday. And instead of referring to, for example, Sunday as Sunday, I can refer to as the element in the first index. So, and for example, Tuesday is the element in the third index. So if you're coming from a different programming language background, this might be a little not intuitive because in some programming language, the index starts from 0 instead of 1, but in R, it actually starts from 1. So that's with indexing. Okay, and then we can go back to R to look at some examples. So on line 188, I defined a numeric vector called A, and then I give it the value of 2 all the way to 10. To run this, and I can remind you of what A is. You can see in the output region, 2 all the way to 10 are printed. So if I want the first element, that means I want 2. I could write A square bracket 1, and this will give me 2. So similarly, could someone please tell me how to access the 5th element? I'm going to print out A again so that you have it. Does anyone want to volunteer? Yes, no, maybe so. Anyone? Okay, I'm going to start off by typing A. And then a square bracket. And then since I'm accessing the 5th element, I'm just going to write 5. So if we count this 1, 2, 3, 4, 5, number 6 is going to be printed. So let's check the output. If we actually run this line, 6 will be printed indeed. So what would you do if you want to access the number 9? And again, I'm going to remind you all of what A is. Anyone? How to access the number 9? No? Let's track A8. Indeed, we have number 9. That's perfect. So I can also have a character vector. For example, I'll call it day. This is what day looks like. I can access consecutive numbers, consecutive elements. For example, I want Sunday all the way to Wednesday. So I can just write day 1 colon 4. That will give me the elements 1 all the way to 4. And I can also access non-consecutive ones. For example, if I want to access elements on index 1, 3, and 5, I just need to put a numeric vector in here within the square bracket and access the elements. So if I run line 201, Sunday, Tuesday, and Thursday will be printed. Okay, perfect. Does anyone want to tell me how you would access Thursday and Saturday? Anyone? No? Okay. I will start off. No, okay. Day, square bracket. Anyone want to help me complete? C, probably. And we need to count the index of Thursday and Saturday. So 1, 2, 3, 4, 5, and 7. Right? 5 and 7. If I run this, I get my Thursday and Saturday. Okay. So now we know how to subset with vectors. We will talk about how to subset data frames with index. So subsetting data frame is a little bit more complex since there are both a row and a column component that we need to tackle. So in the square bracket, instead of only having one element, we actually need to have spaces for 2 different elements. So the first blank space you can see here will tackle the row component. The second element over here will tackle the column component. So similarly, we can also subset by index. And I can give different role, different index. For example, row index 1 just means the first row index 2 just means the second one. And if I want to access a specific row, I will just put the number, if you're subsetting with index, over here in the orange box. And we can do similar things with column. So the column index 1 represents the first column, the column index 3 represent the last column. And then if we want specific columns, we can just put the numbers or the vector of numbers in this grayish position. We can combine those two to get an even more specific range of values. We can subset by row and column. So now we need to fill in both of the places. For example, if I want to get ID number 1, so that is the first row and first column, I'm just going to write ERC follow 1, 1. And for example, if I want to access my name, that will be row number 1, column number 3. So I'm going to say ERC follow 1, 3. So we're actually going to see this in R. Okay, so starting on line 212, that's 212, we can run this ERC follow because we defined it earlier, and if we run it again, R is going to remember what value we assigned to them and print out the corresponding value. Like I said earlier, we can subset the first row, and that is just 1 comma. The second entry is left blank because we are not doing anything. We want all of the columns. So if I run this, only the first line will be printed. And next, we can also subset by columns. So let me bring up this old ERC follow data frame again. If we only want the last column, the name column, there are a couple of ways to do it. The first one is to index by just by the index. We can say it's the third column that we want. So that will pronounce the name of the ERC follow. That's Grace and Weenie. And we can also, instead of using number 3, we can see different column names, and we want the third column. So we're just going to grab the third column name, which is name, and we put it in the second entry right here. So that will also print out Grace and Weenie. Line 219 is actually the most common way that people access row elements. Is you first have your data frame name, it's called ERC follow, and then a $sign. And then after the $sign, you put in the name of the column name, in this case, name. So do this to get the same value. Okay, so now we can combine the row and column in subsetting to get an even smaller range. For example, I want the first row, but I only want the first and last column. So there I'm gonna have the ID and the name. And we can also only get the name Grace. So before on line 219, we said that this will return a vector with both of the names, but I only want the first name. So then I do that just to get Grace. A side note, actually, so you have to refer to a column, you cannot simply say the column name. For example, this is, oh, sorry. This name is defined earlier, but if, for example, I were to access the column uni, I cannot just type in uni and then run this to get a result because R does not recognize this. So you have to associate it with the data frame. So I'm actually going to comment this out because this is going to help. Okay, any questions so far? Everything clear? Perfect. So now we know how to subset with index. We're actually going to subset by logical operators. So what are logical operators? Those test conditions and output either true or false. For example, I can ask, is Grace a ERC fellow? Yes, so that's true. Is Grace a DHC fellow? I'm not a DHC fellow, so it's false. So some of the logical operators we have, first one is equals equals. Remember with the single equal, that's kind of like I'm telling you what the value is. And my way to differentiate this with the single equal is that two equals sort of emphasize the fact and ask a question, is that really equals to? So the equal equals checks for equality. The second one is a greater or smaller sign. And that's similar to the one you have in math. Is 5 greater than 1? Yes, true. The third one is actually not equal. So we have an exclamation mark followed by the equality sign. Perfect. So how are we supposed to use this to subset? For example, suppose I want to check whether in our data frame, in the ERC fellow data frame, there is a fellow named Grace. So you go on and you check the names, whether one of them is Grace. So the first one is Grace, so then it is true. The second one is not, so it's false. When you're subsetting, the length of your condition from here, we can see that the length is 2, should be always equal to the number of rows in your data frame. And a very special thing is that you should always put in your condition in the row position. And only the row associated with this true value is going to get printed. So for example, if I were to run this line, only the first row is going to be printed. Okay, so we can now shift to R to demonstrate. For example, earlier we said that, for example, I forgot what X is. I'm just going to type X in the console to see what X is. So X is 5. So on line 239, I'm going to check whether that's equal to 4. So that's not equal to 4, so it outputs false. And we also want to check whether X is greater than 6. And that's also false because X is not greater than 6. Unlike other programming language where checking equalities in text can sometimes be an issue, it's not the same thing with R. For example, if I define ERC, the value ERC, and then I assign it to the variable txt, I can check whether txt is ERC. That is ERC. And I can also check whether txt is not DHC. And that's also true because we are two different, the texts themselves are different. So subsetting with them, just a reminder of what this data frame look like. We have 2 rows, 3 columns. And I want to check whether one of the name is Grace. So my condition is actually, I check for the column. So I want the third column. And I want to check whether one of the name is equal to Grace. So this is actually my condition. And I am passing this condition value into a variable. I'm just going to call the variable condition. And then we can print out condition to see. So the first one is true. That means like the first row has the name Grace, but the second one doesn't. And then we can subset with the condition to only get the first row. And sometimes you can also see people combine these 2 steps into 1 step. So this is our originally first step. And this is also very common practice. Sometimes people's codes get longer because they combine different steps, and this will return the same results. Any questions?
Why are we getting, why is this one false?
The second one? Okay. So
When you ran the first.
Right. So here I'm checking whether ERC fellow, I'm subsetting the ERC fellow by just looking at the third column. So you have the third column here. And I want to
tell you that the first name is great.
Yes, exactly. Any other questions? No? Okay. I think I'm just going to very quickly run through task 1. So for the original DF with the schools and predicted income, I can also check, if I only want private schools on my list, my condition is going to be type equals to private. And then I can assign a new data frame to this. I can check the dimension. Before we have about 728 rows, now we only have 450 rows. That means some of the schools are not private, got deleted. We can look at the head. And if we scroll back to the type, you should only see privates. You should only see private around here because that's our condition. I'm gonna skip over tasks 2 and 3 because we're short of time. But if you have any questions about tasks 2 and 3, please feel free to come to us and we'll help you. Okay.
Are there any
So
questions, by the way?
yes, questions? Questions? Okay. So the last section is actually gonna be a start to create your own data analyst project in R. So in this series, we have a research question. Our research question is actually how much is the college wage premium? So a lot of people say, okay, going to college give you a wage premium. and we want to find out how much is that. So some of the leading questions, you can read through bullet point 2 through 4, because those will be answered in the next workshop. However, in this one, we're gonna look at the distribution of early career pay. Okay, so some of the approaches when you have a data set and you have a research question, how are you gonna approach to answering those questions and then just to, formalize your report? So the approach is actually to look at the summary statistics of the data. So then you get a better understanding of the data and to clean the data if needed. Sometimes the data might have missing values. Sometimes there are negative values where there shouldn't be any. And the third step is actually to use data visualization to attempt at a problem. For example, you want to look at certain trend, so you can sort of visualize it in order to find a solution. Or sometimes you might want to revise your hypotheses. And the last step is to use linear regression or any other regression you need to actually tackle the problem and to find a statistical significant results. Okay, so if you scroll down to line 296, we can look at the names of our DF again, just to remind ourselves what the data is about. So we see something early career pay, that seems like something that we're really interested in. That is actually our variable of interest. So we are gonna explore what this data look like. For example, we can look at the mean, the median, the max, and the mean. And I'm just gonna run these together just so then the results are printed all together. So the purpose of doing this is sometimes for the mean value, there are negative values, and for pay especially, you don't really want negative value unless that's something you want to study. So typing, although you can see the results from typing in for specific functions, there is also one function called summary that does all of this for you. So when you put summary and then the DF early career pay, you see the mean, the median, the max, as well as the first and third quartile values. So then I'm gonna skip over this practice question. And remember, we have a variable in our original data frame called type that just says whether your college is public versus private and probably some other type. So this is actually a categorical value. So if we do summary on this, the output is not really interpretable. Okay, I know the class is a character and the mode is a character and so what. So for categorical variables, we actually have a function called table where we can run this, and this will actually give us a frequency table. So we have about 451 private universities and about 200 or so public universities. Okay, so we do see this one for-profit universities, and studying this one point might not give us actually a statistical significant result. So in the data cleaning part, I'm actually going to remove this. So my condition is that if the type is not for profit, I'm going to keep it. If it is, I'm going to delete it. Okay. So notice here that I call this variable df again. And the good thing of doing this is that you don't need to memorize. Okay, so I call that one df1, that one df2, the original one is df. You don't really need to remember this. However, the bad thing is that once you do this, you are not able to get your original df back. Well, unless you reread in the function, but this will overwrite whatever you had for previous df. So you might want.
But that's also, by the way, for everybody, like the benefit of R, like with something else, let's say if you deleted something from it, like Excel, if you delete a row and later you open up the document, whatever, you can't go back. Here, yeah, in this like session, technically you can go back a step, but what you could just do is rerun from the beginning. And in R, all you have to do is go to run and say run all chunks above, and it'll just redo all the steps and you won't have lost anything. So that's one benefit of R that you wouldn't get with something like Excel.
For people on Zoom or whoever is watching the recording later, this is also a benefit. For example, in Excel, if you delete a row, it's permanently deleted. However, in R, you can rerun the code previously to get to recover the original files, so to speak. Okay, so now we have cleaned our data. Since we want to sort of figure out the early career pay, like how is that distributed? Yes. So
The row number up top should have changed. I mean,
right.
that's one immediate way. So you could also run dim again and see if that one is removed.
Right, so you can see dim GF. Remember previously we have 728 and now we have 727. And in here we had that for profit is 1. So that should theoretically remove 1 row and it right.
If you also wanted to check another way is if you ran that table function again, and it should give you almost the same result. The only difference should be there should be no full profit result.
We can actually see the table function. So we can write the table df. We hit F.
You have $ type.
Oh, right. We have table df and then we are doing type. So we can now see in the table output, they're only private and public. So we've successfully removed the for-profit observation. Okay, perfect. Any other questions? No? Okay. So like I was saying earlier, we want to sort of figure out how this early career pay variable is distributed. And we can do so by looking at a box plot. If you directly run this line and scroll down to see the output, I mean, this is a graph, but it's not very informative in a way that I don't know what is on the Y variable, I don't know the title, and there are a lot of outliers that is squeezing my plot that I don't see it very clearly. So there are a couple features that you can actually specify in the box plot function that will, first of all, remove all the outliers by this outline equals to false. It will give your plot a Y label, this YLab function. This will give you a label right here. And this main sort of main equals also give it a main title. Okay, so another way to visualize a distribution is to actually see the histogram. So if we run the histogram, and by specifying different elements, for example, the X lab, the Y lab, the main, you can also get a pretty descriptive histogram that sort of describe the distribution of early career pay. Okay. And we can also create a scatter plot. So for scatter plots, both the X and Y has to be continuous variable. So in this case, I'm creating a scatter plot of early career pay versus STEM percentage, where my X lab is my STEM percentage and my Y lab is my early career pay. And somehow you can see a upward trend. In order to better see this, we can use this outline function to actually plot a best fitted line, or if you're more familiar with Excel, it fits a trend line. So a very tricky part with this outline is that you have to run it with the plot, or otherwise it doesn't know where to add the line, and that will cause an error. So when you run these together, you can see that, okay, I have my scatter plot with a trend line. Any questions? Errors? Okay, perfect. And for the next parts, there are some different things you can do with R. Unfortunately, we don't have enough time to get into it. That's why you should come to the second workshop where you get all of these tackles. But I'm just gonna run these codes to show you some pretty cool plots. For example, you can have distribution based on type of college. We have private versus public. And we can also have histograms. For example, this histogram will show you the distribution of private colleges. This one will show you for the public colleges, and we can lay them on top of each other to further analyze the trends. We can do linear regression. We can fit a linear model. We can get the intercepts and the slope. And it's the statistically significant results. We can do a linear regression. And we can also find out whether your college tuition pay off. So whether you're gonna make more money than your college tuition, we can actually find that. So most of the values are positive. That means that you're gonna definitely make more according to this data set than what you paid for college. And right. So to wrap up, what we talked about today, we talked about R Studio, R Markdown files, some variable assignments. We talked about data objects, including vectors, data frames. And in data frames, we talked about reading in CSV files. We talked about subsetting, whether with indexes or with logical operators. We talked about EDA, which is exploratory data analysis, where we look at the summary outputs. Actually, if you would go back to R, we can actually knit this beautiful file into a Word document. So first you hit save, and we have created some errors when we actually run this. So for example, if you scroll to line 87, and if you type, I'm gonna wait till everyone is at line 87. You can type a hashtag in front of the line that will comment out the code. And by commenting out the code, I just mean that when R hits that hashtag, it's gonna ignore it. So let me check whether we have other errors.
The reason Grace is doing this is because to be able to knit, you can't have any errors in your document. So we built in some errors so that we have to take them out.
Right. I believe we don't have any more errors. However, we can knit and see. So to knit, we hit on the top bar, we have this knit button with the little like ball, and then we hit the arrow next to it. We can do knit to Word. And then it's knitting. Okay. And now we have created our beautiful knitted documents where you have all of your commands and all of your outputs as well. When you scroll down a little bit, we also have our graphs. So we have our box plot, we have our scatter plot histograms, etc. So this is your knitted document. Sometime your professor might want you to submit a PDF. You can directly just convert this doc into a PDF file. Okay, so that's with knitting. Oh, and the knitted file will actually be stored in the same directory as your R Markdown file. So if you close that and then you're afraid that you cannot find it, it's just in the same folder as your R Markdown file. So if you want to do more with R, there is an intermediate workshop next Monday, 4 p.m. at the same location, same time. We're going to answer more questions about college wage premium, which is very interesting. And we're also going to be talking about libraries and packages. More specifically, we're going to be talking about dplyr, which is a package that allows you to subset and to data wrangle a little bit faster. And there are also ggplots, which is a package that can let you create very, very beautiful graphs like I have shown over here. Thank you so much for attending this workshop, and I hope you see you guys next week. This PowerPoint is shared with you in the doc, and you can find our website, our walking hours, and emails, etc. Thank you so much.
Remember, just as Arushi mentioned in the beginning, if while you're working on this or you want to learn more R, you can always come into the help hours as well, and the fellows will be able to help you out. So it's a little bit easier if you come in saying, well, I'm trying to do something, how can I figure it out? Or to come to one of the workshops. That way, both like the workshop is already kind of pre-designed, and if you come in with a project, we're able to help you because we know like we'll help you try to do the thing you're trying to do. So, oh, I want to practice the data set. And that's also the best way to learn R, like by practicing. Just make sure you fill out the sign-in sheet before you go.